This conference will now be recorded.
Let us start with the session. So today we'll start with UVM course. Uh, the, the UVM course is divided into two parts. One is the essentials training, which is part of the front-end training for freshers course. And this would be generally sufficient for a fresher. Okay. The second is UVM advanced, which would go for another 4 to 5 weeks. It is for those who enroll for complete UVM course. Generally, for a fresher, this essentials is sufficient. It covers all the important things that are required for a fresher. I mean, sufficient for 1 to 2 years experience. Up to 2 years experience, this is sufficient actually. All the things. Okay. You know how we do theory and lab sessions, right? Uh, Again, some guidelines is be in sync with the trainer flow. Whatever I teach, you try to do the same topics. Okay, and complete assignments as per the schedule. That is where you will really benefit out of the course. Next. What is covered in the essential course and advanced course is listed here. As you see, these topics are sufficient for you. Okay. Advanced things like sequence library, TLM 2.0, synchronization classes, policy classes, pools. These are advanced and many times we don't even use it actually. Even in the someone with 5 to 10 years experience will not use many of these things actually. But it's just for a knowledge, you can learn some many of them. 95% of the time, 90 to 95% of the time, we use this only. So hence we cover only those topics. Okay. So let's start with the UVM overview. UVM stands for Universal Verification Methodology. It is a open source methodology. What is meant by open source is uh, the UVM system Verilog files. Essentially, UVM is a system Verilog. There's if you implement, I mean, if you look at UVM, these are the pre-implemented system Verilog classes. Okay, these are called as library files. These are openly available. You can just go to the internet. There is a website called as accelera.org. From there, you can download the library files. Users can view the code and users can use the code without any licensing. That is what we mean by open source. You don't need to purchase any license or anything to use UVM. So who has developed it? It is developed in collaboration by Mentor, Synopsys and Cadence. These are the three companies who develop the EDA tools. These companies come together and develop this methodology. UVM can be used with any of the simulation tools. Means you can use it with QuestaSim. You can run UVM code with VCS, Synopsys VCS, and also with NCSim. UVM is essentially system Verilog base class. I mean, there is no big difference between SV and UVM. As I was already telling you, in UVM advantages, you don't again need to learn data types and operators, anything. Whatever data types, operators, everything you learned in SV is part of UVM. Only thing is how to do the things efficiently is what is explained. So if you understand how SV has evolved, you know, till 1990s, Verilog was used, and the Verilog verification was also done with Verilog only, because designs were simpler. With design complexity increasing, Verilog became bottleneck in the verification process. So why it became bottleneck? Because Verilog has fewer constructs. I mean, it has only module, always, assign, initial, some few operators and few data types. That was not sufficient for efficient test bench development. Like it doesn't have functional coverage, interface, function. different types of arrays, mailbox, queue, lot of things were not there. Hence, it was getting difficult to do test bench development using Verilog. That is where object-oriented programming based HVLs evolved in the late 1990s. So what they started, see, Verilog, is it object-oriented programming? No, right? They found that for all these problems, to develop a test bench in an efficient manner, the solution is object-oriented programming. That's how C++ evolved. Because you view the things at a bigger level where everything is put into one unit, what we call as encapsulation. There are some benefits which you get by moving to object-oriented programming based languages. That is where few new languages came. Those languages are Vera and Specman. These were quite famous during 2000 and 2010 actually. If you go around that time frame, you will see people were using, instead of SV, people were using Vera language to set up the test bench environment. Specman E, it's also one more language, was used for test bench development. Then you see that again became a division where some companies were using Vera, some were using E. A lot of confusion was there. Then IEEE wanted to standardize it. Then they gave a standard called as IEEE 1800, which refers to system Verilog. EDA companies developed HVL. Like, why did these companies, like Vera was developed by Synopsys, Specman E was developed by Cadence. So EDA companies developed HVL and methodologies to promote their tools. So when you purchase Vera, when you use Vera language to set up your test bench, like you developed BFM generator, if you use Vera, you have to use Vera language. It is no different from actually system Verilog. A lot of things are common. Okay. So automatically you have to use their tool only. If I'm developing test bench using Vera language, I need to use Synopsys VCS to compile and simulate that test bench. So hence, they developed these languages because they wanted to sell their tools. Okay. So, but then as I said, IEEE came up with a standard. That is where all the tools started supporting SV. Then because it's one single language, companies started moving to SV. Around 2010 or little earlier time frame itself, people started moving to SV. As the people started moving to SV, Vera and Specman E died. Now very few companies use Vera, very few companies use Specman languages. Then how UVM has evolved? You see, uh, if you take two different designs, each having two interfaces, how will the test bench will look like? Something like this. A design which has got two interfaces, one master interface, one slave interface. This is how the test bench will look like. Even if I take, doesn't matter what is this design is. It can be a DMA controller, it can be an Ethernet MAC, whatever. If a design has two interfaces, how many interfaces are there? Two. Test bench will most probably will look like this one. BFM will come here, generator will come here, monitor will come here, functional coverage, register model and reference model, checker, monitor. It looks same. So what industry has noticed is there is lot of commonalities between test benches. You take 10 designs, you develop 10 different test benches. They have a lot of things in common. Those common things is what we are implementing as a methodology. They give that common things as one methodology. You follow this methodology. And also they will give those common things as base classes. Whatever is common across all the test benches, they provide as base classes so that you can start from that base class and develop what you want. So you save time in development of that base class. Then they also give us guidelines on how to do everything efficiently. So when I say base class, to develop a BFM, what does BFM stand for? First functional model. UVM provides with a class called as UVM underscore driver. So there is a base class called as UVM underscore driver. Now you may ask, what is base class? It's a class which is provided automatically implemented in the language UVM. You use it as a base class. Class APB driver extends UVM driver. So whatever functionality that is present in UVM driver becomes part of APB driver. So using inheritance, you will create whatever you want. Let's say I want to develop APB sequencer. I will say class APB sequencer extends from UVM sequencer. Now you may say, what is driver? What is sequencer? I didn't hear. BFM is driver. When you come to UVM, BFM is called as driver. Generator is called as, that's all. No difference. Very similar. Of course, few small differences are there, but they're very similar. Okay. Monitor is extended from where? UVM monitor. Functional coverage is extended from UVM subscriber. There is no UVM coverage. It is called as UVM subscriber. Scoreboard is reference model is extended from UVM scoreboard. Register model is reg block. Checker is from comparator. Monitor is from UVM monitor. Slave model is from UVM component. So in summary, these are the very few things that we are seeing. There are a lot of other base classes provided by UVM. Why we use the term base classes? Because they are supposed to be used as a base class and you have to inherit, extend and use them. That's why we use the term base class. Actually, they are classes. You're supposed to use them as a base class for creating the new classes. So this test bench architecture diagram shows which UVM base classes will you use to develop different test bench components. What is the advantage of using this UVM base classes? Because when you extend your driver from UVM driver, whatever is the common functionality of a driver is already present in UVM driver. You just have to update it with your new functionality. Okay. So let's go back. Okay. So when we see, just to understand how UVM has evolved, you consider two different designs, each having two interfaces. When we develop the test bench for both, these test benches have a lot of things in common. Okay. Where you develop generator, where you develop a BFM, monitor, coverage, everything is similar actually. Only what differs, the protocol related and the design related things will differ. The skeletal structure remains. So what UVM does is it provides base classes with common functionality already implemented. Whatever is common to all the drivers is part of UVM driver. Whatever is common to all the sequencers is part of UVM sequencers. Because of that, you don't have to develop that common thing all over again. Okay. These base classes can be simply understood as with an example of a pizza. You have a pizza base bread and flavors. It's just that in pizza case you have to go and purchase the pizza base. Here you have unlimited free pizza bases. They're giving pizza base free. You just have to add the flavors. You don't have to purchase. You don't have to license. So again, there are two options. One, you say that no, I will develop again base from scratch. Second is what? One is already freely available. So people would always start with what is available. Okay. These UVM base classes can be used in every test bench development. It saves the time in developing test benches, test cases, everything. How much it saves is if I use system, if I use Verilog, complete a verification. Let's say if I take some complex design, let's say like Ethernet MAC verification. Verilog might take 6 months to do. System Verilog can do the same thing in let's say 4 months or 4.5 months. UVM can do the same thing in 3.5 months. That's the kind of improvement you get. There is no additional cost actually. You don't have to purchase any new tools, new licenses, nothing. You save by 1 month time what you can see a significant improvement, right? When you move from Verilog to SVSVT, how do you save this 4.5 to 1 month? What is that makes it possible to save that 1 month is base classes already there. You just have to extend and implement only additional functionality. Second is there are guidelines. Guidelines means what? How to develop test case, how to develop sequences, how to develop driver. Guidelines are there for everything. You don't have to think everything. So because of that, you know the approach directly. So you directly start. Let's next understand what were the methodologies before UVM. Was UVM the first methodology in VLSI? No, there were a lot of methodologies. Finally, everyone ended up using UVM because it is more efficient. So there were different methodologies developed from year 2000 onwards itself. I mean, you starting from 2000 year, there were methodologies already present. The UVM started becoming more prominent from 2008, 2009. You can say 2009 onwards, it became more prominent where industry almost started shifting to UVM. What were the methodologies before that? There was a methodology called as RVM, which is reference verification methodology. It is based on every methodology is based on one language actually. Methodology is not independent. Methodology has to be based on some language because language is the base on which you develop what is the right way. So RVM was based on Vera and it was developed by Synopsys. There was one more methodology called as ERM, which is E reference methodology, which was based on which language? Specman E language. This is a language, okay. Specman E is like a language, like C is a language, Specman E is a language. Based, it is developed by which company? Cadence. AVM, which is Advanced Verification Methodology, which was based on SV, developed by Mentor Graphics. Then came VMM and OVM. VMM, see, till this point, Synopsys was using Vera based. Then Synopsys wanted something based on SV. Then they came up with a methodology called as VMM, Verification Methodology Manual. Okay. Then came OVM, which is Open Verification Methodology. Finally, people started thinking, do we really need so many methodologies? It is again going back to same thing, Vera, Specman, all that. Right? So that is where companies collaborated and they said, let's have one common methodology which industry will use. That is UVM, Universal Verification Methodology. It is a superset of all above methodologies, a lot of concepts taken from ERM. ERM is very, very important methodology among all of them. They have taken a lot of features from ERM, and that is all it is. Now let's understand what is the need for methodology. Can someone tell me why do we need methodology? What is the need for methodology? It reduces the time taken to do the verification. Simple. That's the only reason. Otherwise, you don't need methodology. If you have unlimited time, you don't need methodology at all. I mean, it helps us do more things in a less effort. It helps us do more things in with less effort because lot of things are already present in the language itself, methodology itself. You don't have to redo them. So now let's understand. There's a need for methodology, reduces the time taken to set up the test bench, reduces the time taken to develop test cases and debug those test cases. Even developing test case becomes very easy. Debugging those test cases also become easy. It helps with reusability and modularity. You can reuse the things very easily. I mean, whatever is developed for some other design, some test bench, you can reuse it for this design. And also helps with modularity. Need for methodology, like develop test bench for different designs. Let's say you take some different designs, USB controller, DMA controller, memory controller, SP controller. Lot of things are common. As I said, there are a lot of things common in all those test benches. For every interface, we need to develop BFM, generator monitoring coverage. For every interface, we need to develop scenario and transaction. So what they felt is these are all you see common. So they implemented those common functionality only as the base classes. See, they cannot, UVM cannot give you APP driver. Can it give APP driver? Because it will then become very specific to APP protocol. UVM cannot give you mem transaction because then it will become specific to memory. They will give you common things like UVM transaction, UVM driver, UVM monitor, where the base functionality is present. From that, you extend and implement the required function. Methodology brings uniformity into the verification flow. The way verification engineer do the things. Uniformity means what? You know the approach, you know it's like a properly documented. How to develop test case, you know the steps. You know that class APP transaction test extends from UVM test. Then what to do? There is a guideline for everything. Because of that, everyone is in sync. Everyone knows if you say we are doing something in UVM, we know that this is the approach we have to follow. So everything user can think of in functional verification flow and test bench development is already documented. That means if you ask me how should I print a message in system error, how will you do? Dollar display. In UVM, there we use something else. All those things are properly given as a guidelines. For example, you want to develop test bench architecture. You want to do the test bench component coding. You want to develop coverage. So UVM will immediately tell you that base class is UVM subscriber. You have to register it to the factory. You have to define function new. Then you have to implement function right. So guidelines will be there. Those guidelines you just have to follow. Initially, it will look little complex because a lot of base classes are coming into picture. But as we go forward, it is a lot easier compared to system. I mean, if you ask me, can I use mailbox? Can I use associative array? Can I use semaphore in UVM? Can we use that? We can't use. We can use everything because SV UVM is nothing but SV only. So whatever is there in SV, you can use in UVM, and UVM also provides you some additional things. So like test bench component coding, how to connect the test bench components, how to do the test case coding, how to develop scenario, how to print the messages, how to check design output, how to decide when to end the test case. See, generally, how will you decide? You'll put some delay, then you call dollar finish. There are some guidelines you follow, right? When to finish the simulation. How to report test case status. All these guidelines, all these things are part of the methodology. All these guidelines are part of the methodology. You don't have to think a lot about it. The UVM, when you read through the UVM user guide, it will tell you how to do each of them. Because of that, everyone is in the same understanding. Like if one person knows thinking how to connect two components, other person also knows this is how he will connect. That is the advantage of methodology. Methodology means what? English meaning. What is the approach you are following for doing something? Universal verification methodology. Mean verification methodology. Universal means what? Not the universe. We are talking about the world. People in the VLSI world, how they should do the verification. That methodology, that approach is what we are calling as universal verification methodology. UVM provides guidelines on how to do all these things efficiently. uh, we wanted to use this design as reference, but we understand, right, why we need UVM, so no need to really go through all these things again. It will confuse you a lot. What does UVM consist of? I mean, when you say UVM, what exactly is part of the UVM? Tell me, can someone tell me what is part of UVM? What is part of, what is there in UVM? Lot of pre-implemented classes. First thing is UVM is not a tool. Like QuestaSim is a tool, VCS is a tool. So UVM is not a tool, not a compiler. It is a methodology developed on top of system Verilog. So in summary, UVM is essentially system Verilog. What does UVM consist of? I mean, what is there in UVM essentially? Hundreds of base classes, lot of parameterized macros, means 300 plus. It could be a little bit different. Multiple utility base classes, means this is a subcategory of this one only, no different. It's subcategory. Those utility classes are called as factory, config database, resource database. We'll discuss all those things as we go forward. Other than that, guidelines on how to do each aspect of the test bench development. Means it provides the guidelines, how to do test case coding, how to write test bench component, how to connect them, how to come up with architecture. Everything there is a guideline. You remember we have seen the same list previous slide. Next, how things differ in UVM compared to system Verilog. Before that, let's understand why people are moving to UVM. Most of the things in UVM are implemented as base classes. For example, in SV, how do you print messages? Using dollar display, dollar monitor, right? When you come to UVM, even for printing messages, we use classes. UVM, the printing of messages is also done using UVM report object class. There is a class by name. What is the name? UVM report object. Underscore is there. UVM underscore report underscore object. Using that class, we have a methods in that class which are used to display the message. Now you may initially it looks like actually complicating the things. It was very simple in SV. Just use dollar display, just use dollar monitor based on your requirement. Now you may say, why should I complicate it? Why should I use a class? What was simple in SV, why should I complicate in UVM? As you go forward, you'll understand the advantages. You get very fine control about the messaging. let's say some category of messages you don't want to print, you can avoid that. Only some messages you want to print, you can print those. That level of control you will have. Instead of printing every message, see what dollar display will do. Prints every message, right? Dollar monitor also prints every time step whenever things change. But UVM, this report object class, there are some controls we can do where you can decide which message should be printed, which message should not be printed. Because of that, you have a fine control over message. Now, for the projects that we are working on in the institute, you will not really see any difference. You will not see any big difference here. But when you go to complex projects, sometimes the log file could have 10,000 lines, 1 lakh lines. Lot of messages will be there. Going through 10,000 lines is very difficult actually. You can, by using this report object, you can filter it out and only print 200 messages. What can you do instead of printing 10,000 messages? You can only print 200 messages which are important for you. Others you don't print. So this will become easy to debug. This control you cannot have in, it is difficult to get in SV. That's it. Next, event is implemented using UVM event class. In system Erlang, event itself is a data type. When you come to UVM, it's a database class. Test bench components are developed using classes. In SV, all the components are developed from scratch. Point in summary, in UVM, everything is basically converted into class format. So this is about object-oriented programming concepts. I'm not going to start again. Basically, what is that we are trying to learn here is that whatever concepts we learned in object-oriented programming, what all concepts we learned? Inheritance, polymorphism, parameterized classes, parameterized macros, few concepts we learned, right? Static properties, static methods, 7-8 concepts we learned. All those concepts are essential for UVM to work efficiently. Let's say static properties and static methods is not there. You know what is static, right? You access through scope resolution. You can access even without creating the object. Directly on the class name you can access. If that concept is not there, okay, if that concept is not there, then UVM would not be possible. I mean, UVM will be only 10% efficient. That concept of static properties and static methods is not there. UVM is only efficient by 10-20%. That's all, not 100% efficient. So like that, every concept is very important. Like we studied polymorphism. That is also essential. If polymorphism concept is not there, then UVM is not possible. I mean, UVM will be less efficient. Like that, every concept we learned in object-oriented programming gets used during the UVM implementation. So as you know, what is object-oriented programming summary? Encapsulation, inheritance, polymorphism, static methods and static properties, parameterized classes, parameterized macros, and abstract classes. Only thing that's not really important here is, I mean, even if it is not there, it doesn't really make a big difference. But everything else is very important. If any of them is not there, it makes a big impact on you. Okay. I mean, if you ask me, I'm learning UVM. Do I really need to know all this? Not required. I'm just trying to tell you how SV and UVM are interlinked. All above UVM, all above object-oriented programming concepts are essential for efficient implementation of the UVM libraries. Like when I say libraries, base class and macros. Our focus is not to learn object-oriented programming again. Idea is to learn how it is essential, right? Course will not cover object-oriented programming again. First, let's talk about inheritance. You know what is inheritance, right? Can you tell me, in this case, who is the base class? Which class is the base class? UVM object is the base class, and derived class is what? UVM report object. So, what is the advantage of inheritance here? So, what is the advantage? Whatever is the properties, methods of the base class automatically become part of the derived class. So, you don't have to declare them again. When you come to UVM monitor, what all properties does it has? See, name is there. It's see, in this box, how do you understand this? Name is the property, these are the methods. So first box is the, see, the topmost thing is the name of the class. Second is the properties. Third is the methods. This is how you understand every class. Now, if you come to monitor, are there any properties inside it? Are there any methods? Then what is the use of such class which don't have any properties and methods? The use is inheritance. Because of inheritance, it's part of it. All of them are part of the UVM monitor. All those properties. Now tell me, UVM monitor, what all properties are there? Name is there, report object is, no, it is not a property, it's a method. Because as you see brackets, it becomes a method. Parent and children. So how many properties are there in monitor? Three properties. How many methods are there? Around six methods here. Actually, dotted means continuation is there. Some more methods are there. Some more methods. Almost 15 to 20 methods are there. Just because its parent classes have already implemented. So the parent of UVM monitor has already implemented them. So they become part of the UVM monitor by default. Got it, right? Same thing for every class. So what you see here is a good example of multi-level inheritance. Multi-level inheritance means what? In the real life, it's not just my parent, father, my 3, 4 generations, whatever they have, I inherit. That's a multiple levels of inheritance. So the same thing here. Okay. Here, how do you, what else you understand is some classes, let's say transaction, doesn't need report methods, doesn't need these methods. So you don't extend it from here. You extend from directly from the UVM object itself. Understood that concept? See, the transaction class doesn't need these methods, doesn't need these methods. Because it doesn't need those methods, I don't inherit from here. Rather, I'll inherit from UVM objects. Like that, they have created few levels of inheritance. Okay. What will be the problem if I don't use inheritance? Then every class you develop should have all these things. You should manually develop them. Without inheritance, we'll have to develop all those things manually ourselves. Got it, right? This concept. Group, what is encapsulation? Grouping together properties and methods into single entity with methods operating on the properties called as encapsulation. Provides sense of protection to properties methods by declaring them as local protected. I think let's not really go deep into it. I think we know what is inheritance. What is polymorphism? We know what is static properties and methods also, right? We know the advantage of that also. Basically, they provide a concept of shared pool of variables, a pool of variables which are shared across the test bench. Any part of the test bench can access these variables using scope resolution operator. We have already discussed what is scope resolution operator. Uh, Important concepts in UVM like UVM factory, resource database, config database majorly use static properties and methods for their implementation. Without this concept of static properties and methods, it is not possible to have factory resource DB. They don't work at all. Then you know what is parameterized class, right? What is the advantage of parameterized class? Same class can be reused for different requirements. Like you remember in system Verilog, what is the parameterized class we defined? Stack FIFO, right? With LIFO FIFO or something like that we create. Same class can be used like a LIFO. Same class can be used like a FIFO. And same class can support the integers, string, anything, right? That was the advantage of parameterized class. That is very relevant for UVM because in UVM also you want to use the same UVM driver to work like a APB driver, to work like a AXA driver, to work like a memory driver. You want same base class to work like different components, different types of different categories of classes. That is where in UVM they will implement all the most of the base classes as parameterized classes. In UVM they will implement most of the base classes as parameterized classes so that you can reuse them for different requirements. How they will reuse, I'll tell you. Very simple concept. Parameterized class helps with reusability of already implemented classes. As you know, system Verilog supports both type and value parameterization. UVM implements lot of base classes as parameterized classes so that they can be reused for various type and value parameterizations. If you talk about AXI driver coding, class AXI driver extends from where? UVM driver. What is the parameter? AXI transaction. It is AXI specific coding. All the request parameters, there will be one variable called as REQ, there will be a variable called as RSP. Request, REQ stands for request, RSP stands for response. REQ stands for what? Request. RSP, response. They will be replaced with AXI transaction. If I want to develop AHP driver coding, common. Only thing differing is what? Then this will behave like a AHP driver. Since you are passing AXI, it will behave like a AXI driver. Which is the base class we are using in both the cases? UVM driver. How you are creating a different behavior? By passing two different parameters. That is the advantage of parameterized class. If the parameterized class concept is not there, then this would not be possible. You'll have to do a lot of things from scratch. This is very powerful concept because of this. Above is possible only if UVM driver is a parameterized class. If not, we have to develop everything from scratch. Parameterized classes are very important for UVM to work. And you know what is parameterized macro, right? What is parameterized macro? Can someone tell me? What is parameterized macro? What is parameterized macro? Simple definition. You can't even tell a basic definition of what is parameterized macro. What is parameterized macro? What is your native place? Tell me. If I ask you, will you tell some explanation, India, Andhra, all that? Will you tell your place name? I'm also asking same question. What is parameterized macro? A macro with arguments. Parameterized macro is what? Macro with argument. That's what I'm asking, right? Parameterized macro is nothing but a macro which has got arguments. Like we created a parameterized macro for finding a max number xy. So which are the arguments here? X and y are the arguments. Among x and y, you're finding which one is the maximum one. So if I want to find max of a comma b, I will just pass tick max. I'm calling the macro a comma b. I'm passing, which returns the maximum of a and b. Max setup time and hold time. It returns the maximum of setup or hold time. Same max macro can be used for different requirements because it is parameterized. Understand, that is very important. Same max macro can be used for different requirements. Here, one case I'm trying to find the maximum of a comma b. In another case, I'm trying to find the maximum of setup and hold time. So parameterized macros are widely used in UVM. They provide flexibility to reuse the same macro for different requirements. For example, we have a macro by name UVM component utils. This highlighted word is the macro. How many parameters are there? How many arguments are there for it? Only one argument. What is the argument I'm passing? X underscore monitor. What does this will do is, going forward, we will understand that this macro registers AXI monitor definition to the factory. Now, what is meant by registering to the factory? We'll discuss. Okay. Using this definition, user can create AXI monitors objects in the test bench. Let's not really get into it. What exactly is a factory? What is meant by registration? We'll discuss as we go forward. Similarly, if instead of AXI monitor, you want to register AXI driver into the factory, you just have to call the same macro pass AXI driver. So the above line registers AXI driver definition to the factory. Got it, right? Next, UVM component utils is here is the parameterized macro. Parameterized macros reduce coding effort significantly. At times, what requires 50 lines of code can be done in 3 lines of code. Because macro definition is already implemented, you just have to call the macro that 50 lines will come instead of 3 lines. Even though you write 3 lines of code, finally it will be replaced as a 50 lines. I'm just telling 3, don't always think 3 means 50. Macros are widely used across UVM test bench coding, like object and component registration to the factory, reporting of messages, user defined TLM classes. Lot of places macros are used. What is TLM? We'll discuss as we go forward. Some interview questions. I will give you this as a notes. I want you to come prepared with these questions. Again, same concept, whether same thing, whether you do or you don't do, it's your level, your understanding, your interest with the subject. I will do my work. Okay. Whether you do or not do, it's up to you. Okay. Next, now let us talk about get into UVM. Let's start off with UVM base class understanding. Ideally, we should call UVM classes. Why the term base class? Base is coming into picture because this will always be used as the base classes for extending the derived classes. We have already discussed this chart, right? This is very small part of the UVM class. class. Actually, UVM, if you look at, consists of around 500 classes, 500 plus classes. Out of 500, we only use 30 to 40 regularly. Remaining 450, 470, we never use. Most probably we don't have to use also because they are internally gets used. It's like a simple analogy, is like a language where there are a lot of complex words are there which you never use. You typically, we use day to day, whatever words we use, it's only constitutes. Let's say we are talking in one language, Telugu, Kannada, any language, we use only some 200 words every day. But if you refer to the dictionary of any language, right, there will be 10,000 plus words, for example. Same is the relation. Remaining, you don't have to use. Okay. Same in the UVM also. There are only fewer classes which you use frequently. UVM has around 500 plus base classes. We mostly use 40 of these classes regularly. What about remaining 450 plus base classes? Either they are internally used or not always required. So you don't have to look at 500 number, you only have to look at 40. All UVM base classes can be categorized into 7 to 8 categories. They can be classified into at least 7 to 8 categories. Okay. What are those categories? Components which are used for test bench component development. Let's write it. Okay. So first thing is the components which are used for test bench development. These are those things. Sometimes including this also. What is this classes? These are the base classes. These are all used as the base classes for developing the test bench component. If you want to develop APB driver, which base class will I use? UVM driver. And I should see that UVM driver is a parameterized class. Then I should understand what should be the parameter. APB transaction should be the parameter. If I want to create a APB monitor, I will use UVM monitor. This is the first category of base classes provided by UVM. How many classes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So out of 40, 9 are already done. Okay. Remaining is only around 30. What are those 30? Second is the components used for connecting the test bench components with each other. This second category, components used for connecting purpose. How did we connect in system Varila? Mailbox. We don't use mailbox concept in UVM because there is a better way to do the connections. Compared to mailbox, UVM provides better ways of doing connections. When we go to the concept of TLM, transaction level modeling, we will understand how that is improved further. No big difference, but there is an improvement. Because of that, instead of mailbox, we use TLM. Third is the components which are used for creating the scenario. Actually, scenario means what? Generate 10 write transactions, generate 10 read transactions, generate a write transaction followed by read transaction. Like that, you remember? They are created using these things. What are the classes? UVM underscore transaction, UVM underscore sequence item, UVM underscore sequence. These are the base classes which are used for creating the scenarios. The fourth category is the components which are used for reporting purpose, messaging purpose. Messaging means what? Dollar display, dollar monitor we used to do in system Verilog. Instead of that, we follow a different approach in UVM. These are the base classes used for that. Only mostly this one only. We don't use this. This is hidden actually. We don't use it. It is internally used. You got it right. So when I say 40, these are those 40 actually. Some of these are those 40. Okay. Then there are other categories which are not shown here, because this only captures what is really very important. Then there are other categories. Let's go over that also. Creating test bench components, connecting test bench components, creating the scenario, reporting of messages. Then the next category is what? Utility and database classes. These classes are like, you remember in system Verilog we created class mem common, where we kept all the common variables. You remember, right? In UVM, that is standardized as resource database, config database. Like you remember, right? In system Verilog we used to call class mem underscore common. There we used to create static int count, static mailbox. The same concept in UVM is resource database, config database, then factory. This is the fifth category. Next is synchronization of test bench components. So we have synchronization of the test bench process. Like we used to use semaphore, event. Similar things are done using UVM event and UVM barrier. Then there is some concept called as register model. For that we have register model base classes, register base classes. Like this, these are the 7 categories. There could be another 2-3 categories which are not very important for us. About UVM base classes, everything starts with UVM underscore. Like driver starts with UVM underscore driver, UVM underscore monitor. Anything starting with UVM underscore is a UVM related things. It is UVM provided base class or macro. If whenever you see something starts with UVM means it is UVM provided. What all methods are there in UVM sequence by default? If you look at this one, I mean, how do I say what all methods are there? If you go back to this diagram, it is extended from sequence item, which is extended from transaction. This is extended from object. So all these methods and body method, this is part of the UVM sequence based class. So copy, clone, compare, pack, unpack, print, body. These are all part of the UVM sequence. All these are virtual empty methods user needs to update. What is the inheritance hierarchy for UVM test? UVM test is inherited from UVM component. UVM test is inherited from UVM component, which is inherited from report object, which is inherited from UVM object. I mean, that level of understanding you should have about this diagram. Some questions are there. You can again work on these questions. You can even refer to answers here, some of the answers. Okay. Now let us talk about UVM test bench architecture. We got an idea about what is UVM base class, right? There are around 500 plus. Out of them, only 40 are very important, which we use regularly. We have discussed some of them already. 7 categories also we have discussed. Now let us understand how does UVM based test bench architecture looks like. UVM test bench architecture. Uh, this is the diagram. We'll directly jump. The first thing that we develop in UVM is the UVM test bench, top module. It starts with top module. Then we develop, inside that we develop a root, we develop, we instantiate a root, we instantiate the design, and this is not scoreboard actually. This is not scoreboard should be, wait, there is a mistake. A scoreboard should be inside of this. Scoreboard is part of it actually. Okay. So in summary, UVM test bench starts, the topmost thing is the top module. Below top module, what you have? The UVM root design, clock and preset generation, and interface declarations. You know, right? Virtual interfaces. Sorry, physical interfaces. Typically, these are the things that are part of the top module. Below the root, below the UVM root, the root is like the, why the term root comes is, for a tree, root is the starting point of the tree, right? So same way in UVM also, the entire test bench starts from the root. The entire test bench will be sitting below the root. Below root, test will be there. The test case user is running. The test user is running. APB test is instantiated as what? UVM test top. Always in UVM, remember, the test is always instantiated as UVM test. Whichever test you are running, whichever test case you are running, it is always instantiated as UVM underscore test underscore top. This is the common name always. Below the test case, environment class will be there. Below the test, what will be there? Environment class will be there. Below environment class, what is there? Agent will be there. Below agent, driver, sequencer, monitor, and coverage will be there. Also, below the agent, even scoreboard will be present. You see dots I'm showing because the scoreboard will be part of the environment. It won't be outside. Scoreboard will be internal to the environment. What is there below agent? Driver, sequencer, monitor, coverage. Is there anything below the driver? No, driver is the leaf. Like for a tree, leaf is the ending thing, right? Same way for driver, sequencer, monitor, and coverage are the leaf for the test bench, where the hierarchy stops. You see, it is very similar to SV test bench. with some differences. Okay. Let's now focus on understanding what is the differences. Uh, we'll also discuss those differences. Yeah. First, let's discuss the differences. So if you look at this test bench, you have a top module. Below that you have top, which is the instance of UVM root. It happens automatically. It is automatically happens when user calls run test. There is a method called as run test. User has to call that. Below that, what you have? UVM test top. Below desktop, what you have? Top environment. Below environment, you have sub environments. Below sub environments, you have agents. Below agent, you have driver, sequencer, monitor coverage. See, this is the new thing I'm introducing. Sub environment. I mean, if the test bench is complex, you can have sub environment. So let's again revise once. What is there? The topmost thing? Top module. Below top module, root, UVM root. Below root, test. Below the test, environment. Below environment, sub environments, smaller environments. Below sub environment, agent. Below agent, driver, sequencer, monitor, and coverage. What is the difference between environment and agent is? Agent is specific to one interface. If you have one physical interface, you need one agent. If there are three physical interfaces, you need three agents. All these three agents will make one environment. It's like this simple terms. If I have a design with, let's take here, agent is specific to one physical interface. DUT. If assume a design, consider a design with two AXI interfaces, AHP interfaces, and one APP interface. How does the design look like? Kind of. So how many physical interfaces are there? Six. So I will need six agents. I'll need six agents. What are these interfaces? Let's call it as AXI. AXI. This is AHP, AHP, AHP. This is APP. So overall, I will need this becomes APP agent. This is AXI agent. This is AXI agent. This is AHP agent. AHP agent. Putting together these agents, I don't put all agents into one environment. I can do that if you want. That's not the problem. Generally, the practice would be I will call this as AXI environment. I will call this. If I want, I can keep this as environment. Directly I can use the agent itself because there is only one agent. I can directly use agent itself. If I want, I can call it as APP environment. And all these things, AHP environment, and putting together all of them is the top environment. AXA environment, APB environment, AHP environment will go into top environment. Top environment will go into the test will go into root will go into module. It may look complex, but this is how it is done actually. Okay, so this is how the overall hierarchy would look like, the test bench hierarchy. Right? What is a difference between an agent and environment? In system Verilog, there is no keyword called as agent. Generally, we don't use agent. We used to call this as AXI environment. There was no differentiation between what is specific to interface, what is holding those environments. So UVM created the difference by introducing a term called as agent. Now let us understand how UVM test bench architecture differs from SV. In SV, the test bench architecture starts with top module. Below top module, you sometimes have program. Below program, you have top environment. Below top environment, you have sub environments, and there you have generator, BFM generator, monitor coverage, and below top environment itself, you have reference model and checker and scoreboard. When you come to UVM, below top module, you have these two things which are different. Can you see the difference here? And the agents is the other difference. Instead of program block, we are using root. Below root, we are using test top. And below sub environment, we are using agents. Now, these can be master agent or slave agent. Instead of BFM, we use the term driver. Instead of generator, we use the term sequencer and other things. Then, of course, we have scoreboard and checker. Got it, right? Now, let us understand the SV to UVM mapping. In SV, left hand side is SV, right hand side is UVM. Whatever is program, what we used to do with program in SV, the same thing you do with root and test in UVM. Sub environment becomes what? Agent. Instead of dollar display, we use some reporting macros called as UVM info, warning, error, and fatal. We use UVM report info, error, or fatal, one of those categories. Generator becomes sequencer, BFM becomes driver. Most very important difference here is in SV, test is a task. See, test is implemented in the generator. Test is implemented inside the generator. Whereas in UVM, test is a component. Test has a structure. In UVM, test case is like a component which has got a structure. And whatever in SV, whatever we used to call as transaction or packet, in UVM, it is called as sequence item. Sometimes item in short. In short, we call as item. Scenario or stimulus is called a sequence, not to confuse with assertion sequence. See, in assertions we used to study, right? Sequence. That is different and UVM sequence is different. Mailbox is replaced with TLM 1.0 and TLM 2.0. Port implementation export concept. New is replaced with create. Dollar finish. In SV, user has to manually call dollar finish. In UVM, user don't need to call dollar finish. UVM root uses concept of objections to call dollar finish automatically. In UVM, we use the concept of objections. It will call dollar finish automatically. So let's list down the differences. What is the first difference? Program is replaced with root and test UVM test top. What is second difference? Sub environment is replaced with agent. What is third difference? Display is replaced with info, warning, error, and fatal message. What is the fourth difference? Generator is replaced as sequencer. DFM is replaced as driver. Sixth, transactions and packets are represented as sequence items or transaction classes. Seventh is what? Test is a task in system Verilog. The test you implement in the task, right? Run phase, case 0, case 1, that becomes the test case for you. In UVM, test itself is a component. Okay, like that, there are multiple differences. You have to please go through that. Let us understand the importance of run test. When user calls run test in the top module, what happens? Run test is a UVM provided global task. Is run test UVM provided global task means does user need to define or UVM provides it? UVM provides. So all user has to do is call run test. What do you understand from the term run test as a plain English? Run the test case. That's why the term run test is there. When user calls run test in the top module, what happens? Run test present in the global scope. It is present in a file called as globals.svh. It gets called. So as part of the task, root gets instantiated as top. Top memory gets allocated. And top run test method gets called for. Below the top also, there is one more method called as run test that gets called. In summary, the process of test case execution starts with this. When you call run test, the process of test executions gets started. How do you develop a test bench for a complex design? If you have a design with multiple interfaces, how many interfaces are there in this design? 4 actually. Black box you see is the design. The black box you see in this diagram is the design. In this case, there are 4 interfaces are there. One is AXI, one is AHB, one is APB, one is PCI Express. Corresponding to that interface, you need to use the agent based on type of interface. If it is a master interface, you have to use master agent. If it is a slave interface, I have to use slave agent. Here it's a master interface, I used APB master agent. PCI Express is a slave interface, I use slave agent. All these things will go into one top environment. Goes into means what? They get instantiated. The top environment gets instantiated in the test. Test gets instantiated in root. Root in the top one. So there is a specific error. Now, if you ask me, are we going to do this test bench? No, I'm just showing you how a typical complex test bench will look like. Now, if we consider a design with two interfaces, this design has how many interfaces? Two. One is here, one is here. Two interfaces. One has master interface, so I use master agent. One is slave interface, I use slave agent. Uh, Both the agents and the coverage and scoreboard will go into environment. Environment goes into test. Test goes into root, and root goes into top module. This is how typically we develop the test bench architecture. So what we will do is now we will develop a simple test bench architecture. Okay. We'll do for another 15 minutes and we'll end the session with that. Okay. So we won't have any break. We'll take 15 minutes, develop a simple test bench. With that, we'll end the session. Memory test bench we are going to do. You remember in SV we have developed test bench using system Verilog for memory. In Verilog also we have done. Now we'll do in UVM. So for that, what I will do is I'll copy that memory design from some other project. Copied the memory design from some other project. What is the first thing you would start with? Top module. Let's say top.sv or top.tb.sv. So first thing in UVM, whenever you develop any UVM test benches, you have to do include package. So first, compulsory 2 lines you have to do in every UVM code. You don't need to do in every file. One time you have to. In the global scope. In which scope we are doing this? Global scope. Because it is outside a module and outside a class, so it becomes what? Global scope. Why this is required? Because whatever present in the package, like the base classes, the macros, all those will get imported because you did import package star. Star means what? Everything present in the package becomes part of your scope. Next, you follow the regular process. What is the regular process? Module, of TB, whatever name you want to give in module. Inside this, what you do is very important part is this is the simplest UVM test bench where you define top TB and then inside that you call run test. You haven't done any developed any test case, so nothing will happen. So what we will do is user need to tell which test you want to run. Otherwise, how does UVM know which test to run? Correct, right? When you say run test, you need to tell which test you want to run. Let us say mem base test. Mem write read test. This is the test I want to run. Mem write read test. Simple, right? Are we complicating it? No. It is the name of the test class. What is the name of the test class? Mem write read test. I want to do one write, one read. So I'm telling to the UVM that you run this test case. What else do we do typically inside the top module? Tell me. In SV, what else? What did we do? Instantiate the design, declare clock and reset, generate clock and reset, instantiate design, and instantiate virtual physical interface. Connect DUT to the physical interface. Do you want me to explain all those again? So since we don't want to explain again, I will get all those things from the this 19 to 47. This is how many lines? By 28. Line number 6, are you clear? We are declaring clock and reset. Line number 7, instantiating the interface. Line number 9 and 10 I will explain. Basically, it is similar to telling, very simple terms, it's similar to telling mem common VIF equal to VIF. The same concept done in a little different manner. End goal is same. What are we doing? We are putting our physical interface into one bucket. That bucket name is resource database, resource DB, UVM underscore resource DB. Whoever wants to access it, they will access that from that bucket by using the different method. Setting means putting. We'll use a different method that I will discuss as we go. Using get or using by read, there is a method called as read. You can read from the database. For now, let's not get deep into it. Just understand that there is such a concept, which is very similar to line number 11, where mem common scope resolution VAF equal to PAF. So we are putting the physical interface handle into the mem common bucket so that I will be able to access it. Next, line number 15, what we are doing? Instantiating the DUT, memory DUT and all that I'm instantiating. Then line number 26 to 28, clock equal to 0 and generating the clock. Line number 31 to 35, reset. This completes our top one. What is the only new concept that we learned? Two new concepts. Three. One is include and import package. Second, you instead of mem common, use the resource database to put the element. Third concept is what? Call the run test. So as I said earlier, UVM is not going to be 100% different. Lot of things will be common between SV and once this is done, user has to define the test case. See, does UVM know what is meant by write read test? Does UVM know what is meant by mem write read test? No, right? You have to define what is meant by write read test. So that I will define. Generally, in UVM, we don't develop only one test case. We develop multiple test cases. Given a design, do you think you do develop only one test case or multiple test cases? Multiple cases. So UVM has a concept called as library. What is a library? Test library, where you develop all the test cases. All your test cases you're going to develop into test library. So the name will be testlib.test. We are going to develop all the test cases into one common file. What is the name of that common file? testlib.sv. Like we did earlier, we'll develop class mem write read test. Now let us understand what are the steps involved in developing UVM components, UVM test bench components. How many steps are there in total? 5 steps are there. Identify the base class and extend from that base class. Identify base class and extend from that base class. What we have to do? First, identify the base class. For a mem write read test, what do you think is the base class? In the UVM, what do you remember that list? Which was the base class? Base class for a test is UVM test. Base class for a driver is UVM driver. Base class for a monitor is UVM monitor. Right? Second thing is what? Declare any properties. Means any properties are subcomponents. Instead of declare, I will say instantiate. Instantiate any properties are subcomponents. Below the test, what is the subcomponent? Remember the diagram? Below the top root, below root test, below test, what is there? Environment. That is mem environment. Here. We are instantiating environment below the test. That is the second part of it. Third is what? Register to the factory. Remember we discussed one macro to register to the factory. What is that macro? Can you recall? Few slides back we discussed this macro will use for registering a definition to the factory. UVM components. This is called as adding the definition of mem write read test to the UVM. We are adding the definition of mem write read test to the UVM factor. Means we are keeping the definition into the UVM factor. Next is what? Define function name. Function new string name UVM component parent and function. Inside that we have to call super new name command parent. This is a standard concept. I'll explain. What is the name? What is the parent? I'll explain it. Everything in UVM has a name and a parent. Like every person has a name and has a parent. Same way, every component in UVM is like has a name and a parent. This is the fourth concept. Fifth concept is implement other UVM standard methods as per the requirement. As per the requirement. Here, going forward, you will see that I will require a method called as build phase. Now you may be thinking, what is build phase? It is used to create my children. For test, who is the child? For test, who is the child? Environment is the child. Child. For mem write read test, who is the children? Environment is the children. So in the build phase, we create the children. environment equal to new env and this. Ideally speaking, instead of new, I should use a method called as create. Instead of new, I should use a method called as create. But for now, let's not do. In the next session, I'll explain you why create is required. You got it? Env equal to new of env comma this. Then what do we do? We are creating one more method called as one more function called as what? End of elaboration phase. These are standard arguments, standard concepts: build phase, connect phase, end of elaboration phase, which we will discuss in the next session. But for now, just understand that we can define this method. Print topology means we are printing the test bench topology, test bench structure. That also I'll explain. First, since I'm using mem environment, let me define what is mem environment. Class mem environment. What is the first thing we have to do whenever you define? Extends from where? UVM environment. Next thing we do is what? Declare any children or properties. Right now I will stop here because if I start doing, then I cannot stop. I'll have to ideally mem agent will be there, but I will comment it out because if I start doing, then I'll have to go till leaf. Okay, I'll comment it out. Then what else do we do? Third point, register to the factory. What is the macro that we use for registering to the? What is the fourth thing we do? Define function new. I can copy this exact function new. What is the fifth thing? Define any other methods like build phase, connect phase, end of elaboration phase. As of now, I don't need it because I don't have any children. Since I commented my children, I don't need to create it. I don't need to connect my children because I don't have a children. I don't have to connect them. So because of that, as of now, other methods are not required. Why I'm not doing further is because if I develop mem agent, then I have to develop driver, sequencer, monitor, coverage, and I have to do everything. Just to show you how this UVM works, I'm stopping here. So now you have to create rundown. The typical standard process, we log. What is that we want to compile? optb.sv. But source code is present somewhere else. This is the path where my source code is present. In HDD2 homes renew SRC. There is a source is the place where UVM library is present. That path. Once it is done after compilation, what is the next step we do? Which command do we use for that? vsim hyphen no vopt hyphen suppress. Then top underscore tb. Here we need to pass one concept actually. I mean, because UVM is built on top of system Verilog. UVM uses some concept called as DPIs. Internally, UVM has some concept called as DPI. For that mapping, we need to do some mapping. For that, we need to include one file, one path. I'll show you that. This I have to. Please see line number 7, what I did. Whenever you run UVM code with QuestaSim, you have to give something like that. If you are running in your own laptop, then this will be different. This path is specific to the laptop in which I am working right now. Server, it is specific to the server. In server, this file is present in this path. In your server, in your laptop, it may be present in some other path. So you have to identify that. Inside the Questa, inside UVM 1.2, 1.1, something, you have to identify the DPI path and you have to use that. Then finally, you have to do. Now I can go ahead and run it. ECSH, source, home, tools, mentor. I'm setting up the mentor environment. Then vsim, the tool I invoke using the vsim command. Then just do run. Undefined variable mem write read test. Why is it coming is the file I have coded, I haven't included into the top D. You know, right? I have to include all the files, otherwise it won't work. Testlib.sv. What is that additionally I have to include? Mem environment. Agent I don't need to instantiate because I didn't use the agent. Now I can run it. There is a problem in line number 17 in test library. Let's see. End function is missing. Line number 41, there is a problem. Let's see. Right. Don't have to pass any double quote, but still looks like I have to pass in double quotes because it's a name. I have to pass in double quotes. Mem interface failed. Okay. You know, right? I'm using mem interface here. Instantiated mem interface. So what I will do is I'll get mem interface from the other project. You know, right? I'm not going to develop interface again. I'm saving it here. Then include it. See, compilation is happening. I think somewhere I have to call $finished, right? Otherwise, it is never going to finish after 1000 units. You may say $finish not required, right? In UVM. As of now, I didn't implement complete UVM test bench. Once you completely implement UVM test bench, you don't need $finish. As of now, it's incomplete. So hence I'm manually calling $finish. There is some error. Instantiate of memory failed. I need to instantiate memory also, right? Okay. Include memory. Sorry. Memory dot D. It's a Verilog file. Now the elaboration is going through. What you will notice is the structure is getting printed. It's like a table format. In the top, what do you have? UVM desktop. That is the name of the test. What type of test is it? Mem write read test. Below test, what you have? What type of environment is it? Mem environment. Now, if I instantiate agent, let's say going forward, I just do agent. I'm instantiating agent. Immediately, what should I have here? Because I have a child, I need to create my child. How do I, which method I create my child in? Build phase. During my build phase, I create my children. During my build phase, I create my children. For my environment, who is the child? Agent is the child. For environment, agent is the child. So I need to create agent equal to new. Going forward, I will be teaching this concept mem agent type ID create. Instead of new, we have to use this. Now, what is type ID? What is create? This may be a bit confusing. 2-3 sessions later, you will get used to it. Instead of using new, we have to use this. See, in system Verilog, this whole thing was replaced with new, right? This whole thing was replaced with new. You may think this is easier, right? But as you go forward, you will see that it has more advantages. We are creating agent from the factory definition. Now that we are implementing agent, we are instant using agent, we have to define agent. So let's define agent. With that, we will stop the session. We'll define mem agent. Let's follow the same step. What is the base class for mem agent? Uvm agent. What is the next thing we have to do? Children. What are the children? Mem driver, mem sequencer, mem monitor, mem coverage. Then what else do you do? Register to the factory. Then function new. That is, as of now, I'm not going to use this children because then I have to code all those components. As of now, let's keep it like this. Do I need build phase now? If I don't have any children, I don't need build phase. Now to run this, go to top PB. Agent. I run this. Now the new test bench structure will come. Agent coming below the environment. Oh, name is environment only. Reason it is coming environment is I didn't change the name. Because of that, it should have been agent actually. See, below test, environment is there. Below environment, agent will come. I mean, if I rerun, agent will show up. Like this, you can develop entire thing. I mean, you can even do the driver. We can just do it and stop for now. Okay. I can develop mem driver dot sv class mem driver extends uvm driver end class. Uh, let's do it in the next session because again it will require me to define mem transaction and all that. Let's keep these things for the next session. Mem driver, mem sequencer, everything. Once you reach till this stage, once you develop driver, sequencer, monitor, and coverage and understand the template, remaining coding will only take half an hour. Why it will take only half an hour is whatever way we developed driver. In driver, what did we do? Get the transaction, call drive transaction. How did we implement monitor? At every positive edge we collected, we checked valid and ready, and then collected transaction. How we implemented coverage. Those concepts don't differ. Those concepts will remain same between SV and UVM because that is specific to the protocol. Whatever is specific to protocol, it doesn't change between SV and UVM. Okay, so all those concepts will be similar. So once we develop this driver, which takes maybe another 10-15 minutes it will take, if you develop driver, sequencer, monitor and coverage, then we can even whatever functionality you implemented in system verilog, you can reuse the same functionality, exactly same. Let's keep that for the next session. Okay. Initially my idea would be to teach how to develop UVM test bench for one memory example, so that you know what is meant by test bench component, what is meant by TLM, what is a sequence, what is a test case, what is run test. Then we will go into the individual constructs, like what is root, uh, what is objection, what is command line processor. All those concepts will go deep into it after that. So another 2 sessions will take memory test bench. Okay, whatever we did in system verilog we'll do using UVM. Then we'll move on to UVM constructs. So we'll stop here. Any questions before we stop?